So this video is not going to go, deep into the details of how to program these guys and how to use them. It's just more of an overview of like, hey, I had a couple concerns going into this, and I'm sure I'm not the only one out there who does. And the very first thing I thought was, hey, this seems like a really, trendy platform to prototype on, but depending on where you buy it, you might pay anywhere from about $22 to $30 for this guy. And I was thinking, well, geez, if I'm gonna go and build a project, I don't want to drop 30 or 25 bucks or whatever on every project. I mean, some of these should only cost a couple, $2, $3, $5. And so I decided, the very first thing I would do when I got this was figure out how I could not use it. And that sounds kind of paradoxical. It's like, why would you buy it in the first place? Well, I did want to have this platform because it does simplify getting up to speed. And to be fair, without this, I would have had a hell of a time learning some of the lessons I have learned without it. So the first thing that I saw online on the Arduino site was that you could use these boards to program standalone microcontroller chips on breadboards. And I thought, wow, that'd be sweet, great. Now I can actually make projects with just the microcontroller and minimal parts, minimal cost. That proved to be a little bit challenging, but I'll dive into that in a minute. So as for a brief overview of this guy, this is the microcontroller made by a company called Atmel. This is specifically the 328P. Let's see if we can actually focus that guy so you can see the chip. Oh, maybe not. Camera's a little finicky today, maybe. Anyways, this is the AT Mega 328P-PU. And let's see, let's do a speed tour of these guys. So up on the right here, or up in the top left, excuse me, we've got a reset button, and we have a USB. This is the Type B, the Type B end of a USB cable. So the other end would be your Type A, I believe they call it, so you can connect to your computer. So this not only functions as your powering port if you so desire, but it also functions as your serial communication. And the reason that is possible is because of the little microchip right here. And forgive me if I explain this in slight layman terms. This is actually I believe a UART is the acronym, a UART chip, Universal Asynchronous Receiver Transmitter chip. Its purpose is to, well, basically transpose serial data to USB. So when if you plug in like a USB cable here on this guy right here, you will notice that on your computer you will actually have a serial COM port available as well. And it's that COM port that allows you to do serial debugging when you're programming this guy. You can do things like serial.println and things like that. So that little chip right there is very helpful. And at first, when people pick up this platform, I'm sure this is a very minor detail, or it appears to be unimportant. But if you decide to depart from this board, then you will realize very quickly that you do not have a way to debug over serial. So otherwise, we've got a DC jack for alternate power when you don't need to communicate with your computer via USB. And you've got some female pin headers across the top and the bottom. These relate to the pins on the chip. Now the numbering scheme on the board, as you can see, like you got digital 0 through 13 with some tildes to represent some are pulse width modulated capable. And then we've got, let me bring a lamp over here. And then we've got analog pins over here. And these guys are, well, analog. So they're capable of taking in analog information, such as potentiometers and things like that. And then we've got our power zone here. So we've got regulated 3.3 and 5 volt, a couple grounds, these are tied. And your VIN is the, I believe, the actual natural voltage that is brought in via your DC jack or perhaps your USB. Haven't tested this pin very much, but this, I believe, is supposed to be the unregulated input that's powering the board, I think. So in this case, since you're coming from USB, your USB from your computer is already regulated at 5 volts, so it might end up just being a 5 volt regulation that way, or in this case, your AC/DC jack would be regulated at probably 9 to 12 volts or something like that coming in here. So it's probably regulated, regardless. What else do we have? So we have two sets of 6-pin male headers here, and these are what you can use to connect a programmer. So the programmer uses the SPI interface, serial programmer interface, or peripheral, is one or the other, don't quote me on that. And what you can use if you choose not to send your program information over your USB is you can program it through these guys. And you could also do it via the TX and RX pin 0 and 1, but that's we'll leave that for another video. So anyways, the very first thing I wanted to do was pry this chip off my board and stick it on a breadboard, but I was a little nervous to do that, and I did end up doing that and caused a little bit of scrape damage on the sides of these guys. They're quite hard to get off. Wanted to see how it would operate on a standalone board. Quickly realized I needed to set up a standalone crystal. This is a 16 megahertz crystal oscillator that serves as an external clock for this chip. And the reason for that is that these are these do have an internal oscillator of 8 megahertz, but they are much more accurate with an external crystal. And so these chips are bootloaded. Basically, their fuses are set so that they are pre-configured to expect this kind of oscillator, at least in the Arduino world. You can change that if you have a programmer. I don't believe you can change the fuse bits very easily through Arduino. However, you can through a command line tool called AVRDude, which is really what Arduino leans on. So anyways, this is the Arduino, and I quickly realized I wanted to get a standalone programmer to communicate over these kinds of pins. And so I picked up one of these guys. Notice this has a 6-pin connector. One side of the ribbon cable is red, one is not. And this is manufactured by Atmel, the same company that makes the actual microchip or microcontroller. Let's not confuse that with Microchip, the actual competitor company to Atmel. So we have two companies, or two primary companies these days that people pick between for microcontrollers, and that is Atmel for their AVR architecture for their microcontrollers, and then you have Microchip with their PIC architecture. So anyways, this is the programmer. It's a little bit pricey. I think with shipping it's like $50, which is about, you know, two and a half Arduinos. But if you're going to stick with a family of chips, it's probably a worthwhile purchase. You can also purchase some cheaper programmers out there. There's a USB Tiny, which I think is open source. They all have trade-offs. So you kind of just pick one and go with it. So this guy is very useful for programming either directly to your Arduino, you know, right here, or let's bring over a breadboard real quick, and what else? Let me get rid of this line I don't need here. Right, so this looks a little crazy, but let's simplify things for a sec. It's not in terms of all the wires coming from over here. This is a second 18 Mega 328 P-PU microcontroller. I think I picked it up for like $2.50 roughly. Picked up actually a pack of 10 of them, so I got a little discount. They came bootloaded, pre-configured with the Arduino in mind. So that means they came expecting a crystal. So if you try to use this chip without adding your own crystal to the board, then you would not be able to communicate with it. You need to configure your board for the way the fuses on the chip are set when you receive it. Once you do so, you can then use your programmer, or if you don't have this guy, that's okay. You can do it without it, but it's harder. But ultimately, you want to use WinAVR is the package, but AVRDude is the command line tool, and you want to basically switch the fuse bits so that it does not require a crystal oscillator. Anyways, those are minute details at this point. The bigger picture here is if you've got this cable, 6 pins, the question I faced was, well, how do I connect this guy to my chip? And I looked up the information for how to communicate with it, and just like you see, actually, you know what? I have a picture diagram. What I did to interface this, or basically recreate this on a breadboard, was I built a breakout board. And I made my own. You can buy these, but I figured, what the heck. So, this, as you see, is the 6-pin header. There's definitely some, you know, imperfections in this board. As you can see, like, hey, the pins are a little slanted, and on the back side, you know, it's a little bit slanted, but that actually worked out in my favor. I'll show you why in a sec. So anyways, I basically took a bunch of male headers, popped them in a little piece of Vero board here, and ran the pins to the underside of the board like this. Took a little bit of time to get this wired as you see, but basically each pin from that 6-pin collection over here routes up through the board to the underside, and I soldered those on this side. So this allows me, and then I use my printer and printed out some labels, and I put a little red marker here just to indicate which side the ribbon cable should be when it goes in the side with the red stripe. So this took about an hour to make. Depends on how anal retentive you want to be. I'm sure people can do it in a lot less time. So you just snap this guy into your protoboard, or breadboard, whatever you want to call it, and snap your connector onto that end. So let's do that. So go like that, and then we just plug it in. Basically, I can snap it in on the far pins of a given row like that, and all of those will line up. And so now you can just connect your programmer to your USB and call it a day. And so all of these guys are basically set up. We've got the power and ground, which is the VCC and GND pins, and then we've got the MOSI, the master out slave in. We've got the what is this one? The MISO, the master and slave outs. And this one is the system clock, and this one, going to pin 1 of the chip, is the reset. And that's pretty much it. There's just one more thing to mention, and that is, even though you can now program your chip, one of the things I mentioned earlier is you will not be able to debug over serial, because connecting through this guy to your computer, this guy does not have a standalone UART or USART microchip on him, so he will not show up as a serial COM device. And so in order to debug this stuff, if you just have a regular programmer, not something more sophisticated that has hardware debugging, then you need another either breakout board or cable. And what you're looking for is, I think they're called, well, so there's, I believe the chips are called Max 232s, and those can basically function as the same as like these little guys on the Arduino board. Or alternatively, you can buy a standalone cable that has this on both ends. So on this end, you've got, and this is actually quite convenient so that we can see this, but this USB cable happens to be transparent, and that right there is a UART chip, just like, well, more or less just like the one on the Arduino. And this one is, I believe, manufactured by FTDI, and they call these cables FTDI serial cables. So as you can see, we've got a 5-pin connector here, but they're not all even wired up. Basically, you've got ground, power, and I need to put a label on this guy, but one of these, either the white is RX or TX, and the green is the opposite. So there's an RX and a TX pin, just like there are on pins 0 and 1 of the Arduino. And so this would go into your computer. Hopefully you still have extra USB ports. And this guy, he's going to have his power routed to your breadboard power, ground routed to your breadboard ground, and your RX and TX would be connected to pins 2 and 3 of the microchip, because I believe, let me double check, yeah, pin 2 is RX and pin 3 is TX. And this will allow you to see the serial information while you are debugging. So pretty cool. So that is kind of a overview of what you might go through if you are trying to depart from an Arduino board to your own breadboard. And once you go through these growing pains of like probably having a breakout board of some kind, maybe a programmer, although this is debatable, many people actually can use their Arduino, run the lines straight from some of the pins to the breadboard and use this guy as a programmer. And you can do that, but I will say that I tried that first and I ran into a lot of hurdles. But some of those hurdles may have actually been due to USB driver conflicts between installing Arduino IDE and installing Atmel Studio 6. So one thing I do not recommend, for at least for Windows 7 users, that's all I can speak for, is don't install both IDEs at the same time. They seem to conflict with each other. So kind of pick the environment that you'd like to program in and stick with it. So one last caveat is, once you have kind of set yourself up like this, don't think that you must use, you know, AVR libc programming libraries. You can actually still use the Arduino IDE libraries on your standalone chips. And because you are not sending the programs via your Arduino anymore, but you're using a standalone programmer, you actually conserve the space on your Arduino that is usually taken up by the bootloader that you first have to store on the chip. So basically, if I want to program this dude from my computer, there's actually two programs that are flashed to it. There's the bootloader, and then there's the separate program that you write. Whereas on your own, you can just send your program, even if it's written in Arduino. So pretty cool. That's it for now, guys. See you later.